All right.
All right, we're recording and you got the share screen. You're up and going.
All right. So what I'm going to talk about is unusual turnings and techniques that I've done through many years of turning. And the procedure I'm going to use is show a finished item and then talk about how I got there, what kind of tools I used, and what kind of techniques I used, and then again show the finished item at the end. So start out with this one. This is a pepper mill, and what's unique about it is a herringbone design that travels all around the bowl or the pepper mill. Um, One of my friends is using this as a handle for a fishing rod. He builds fishing rods. It could also be used for pepper mill, could be used for handles for turning equipment, could be used for kitchen appliances, a number of things, but it's an attractive design that's 360 in a nature. And I particularly like it. This comes from an article by Darren MacArthur, and I have copies of that article if anybody's really interested. And so we'll go from there. We start out by making three different species of wood, and we make them uniform thickness and uniform size. And I tend to do something a little unique in terms of dimensioning these things quickly, easily, and I'm going to show you my technique on how I create these little blocks. So the first thing is a little video, and the video is showing how I thickness my blocks. So I'm taking I cut my pieces a little bit oversized and a little too thick. In fact, and a lot of times when I resaw, I only clean up one edge, one face, and I clean up the second face with this technique. Okay. To do the sizing of the block, I use the same type of technique. And here's a little video. And here again, I square up basically two sides of the block. I cut it oversized and I get my final dimension on the sander. Okay. All right. The the reason I can get the accuracy I want, and I'm dealing with accuracies to less than 10 thousandths of an inch. And the reason I get the accuracies is, and I'll take a couple minutes to talk about the setup and getting the accuracy of this sander. Um, because I'm doing a demonstration, I didn't want to take the sandpaper off the disc. So this technique would be done on the disc before you applied sandpaper. And in essence, what you do is you put a little dot with a marker here, zeroed out your dial indicator, bring the dial indicator this and bring the dot over and make sure that those two dimensions are exactly the same. When they're the same, this miter slot is perpendicular or parallel to this disc. And that's step one. Okay. Next step is to create a sled. And part of creating the sled is to create a sled with a surface that gives you the perpendicularity. Again, if I do this without the sandpaper, I can use a drafting triangle and create this thing, this fence perpendicular to the disc. I also, whoops, I'm skipping ahead. Okay, let's go back here. I'm also making this screw, keeping this screw loose so that I have some further adjustments at the next step. Another thing I do, I always use corian for my miter slides, and that allows me to have a pretty tight fit that is not subject to temperature changes in the house. Okay, so the final thing to really make sure you're really accurate is to cut a block roughly 4 by 4 by 4, put marks on the two opposite surfaces, run this face through across the sanding disc until all the pencil marks are gone, rotate the block, run it across the sanding disc again, and then measure across all 4 corners of the block. And I use a veneer like this. And when you do that and you get all 4 corners exactly the same dimension, you then have a setup that you will get repeatable answers and repeatable thicknesses and dimensions on your parts. So just as an offshoot, this is not a quick exercise to get those 4 corners exactly the same. Plan on a half a day or so to do it because it's a trial and error thing, and you got to go back and tweak and tweak and continue tweaking. The last thing I create is an adjustable push stick, if you would. It butts against my perpendicular sled thing, and I maintain the flatness by just using it, running it against the sander. And then I use this thumb screw and set up to adjust just for the thickness of the wood or the size of the piece. So in order to make this design, the 3 different species of wood have to be glued together in this particular configuration. And the way I do that is I use packing tape on various blocks and use that for maintaining perpendicularity and for getting the corners nice and clean and sharp and what have you. This picture shows veneer on some of the pieces. I do not recommend that because it does not help in the design. These are pieces that I had left over from a project, but I do not recommend putting veneer on the part. So, okay. This is one of 2 fixtures that were made, and they are 3 squares, perfect cubes of wood cut on a diagonal, and then I glued them in this configuration so that there's this little notch, and there's a bottom, and there's an almost identical block for the top. And when the pieces are put on, the 6 pieces that are glued up in groups of 3, 2 threes, are added together, and that forms one layer. And in order to actually build something like this pepper mill, we just add multiple groups of 3, multiple groups of 3. The next slide here shows the top block, and that's used to start building up the height of the project that you're working on. And if in the case of this pepper mill, it's building the height of the unit. And I usually glue 2, 3 sections at a time, put it in a press, and this is the press that I normally use, and let my glue dry, usually an hour or so while I'm working on something else. But you just keep building your stack until you get enough to do the finished product. Here's a sample of a cutoff, so you can see that there's a herringbone that appears both front, back, and all around the whole unit. Back to the original thing, and that's the discussion on the herringbone design. Okay. Next item. Some years ago, I thought about the concept of open segment in a straight roll as opposed to a brick-like segmenting technique. And I thought, well, what would happen if I did this? So this was the result of that criteria. So we started out, and this is just a representation of the lower portion of that. I started out by developing the taper that I'm looking at, the diameter, the number of segments in the thing, the gap I'm going to have, and here's shows the open segment portion, and this is the closed segment portion, meaning the solids. And let's go back here, and that's the solid portion. This is closed segment ring. This is the open segment ring. Okay. And let's talk about a little bit about how that's built. To maintain the thickness of my pieces, I generally use this drum sander. And so that I put my pieces on a sled with a little stop here and run them through my drum sander. To ensure my drum sander is giving me equal thickness, or the same thickness across the thing, I will take just a scrap stick on the left side and another scrap stick on the right side. I'll either run them through the sander together or individually. But the key is at the end of running them through the sander, I measure the thickness. And if I have the same thickness on the right side as I do on the left side, I have a sander that's giving me a uniform thickness. So much for that. The segments I cut on a sled, and I have quite a number of these sleds, and and I reuse them. You can see I've got holes here that were used for another project, but this is a 24 segment sled. This is where I put my wood, and I'll show that in the next slide. This is my stop, and this is parts for the previous use of this sled. So let's move on to the next slide. Here are pieces that I'm about to cut into segments for the closed segment portion. So I run my I created all my parts as proper thickness through the drum sander. My machine is jumping around a little bit, but let me go back. This is a tool I use to hold the parts. At one time, I used toggle clamps to hold the parts. That slowed me down and was a little bit awkward, and I found that I could hold my parts quite adequately and with this little tool. And all it is a coat hanger bent at an angle with a little handle. And I'll show you how that's used. Here's a little video on how I create segments. So there I created the first slice. And here you can see, here I'm just cutting segments for the project. And that's so much for that. Here you can see the number of segments that I have. And I use Formica disc. They're MDF disc covered with Formica. And then I also use wax on it so that I don't use the glue. But this is a dry glue, a dry thing, a dry fit. So, and I generally adjust my segment cutting fixture so that I get a solid, good, solid one-piece segmented ring. And this slide shows how I hold my ring together with hose clamps. And then I put another piece of MDF covered with Formica on top, and I put it in my clamp, my press, and I hold the parts together. Here is a finished ring. Here is the base of that particular element of segment. So I glue this onto this, and then I build my unit from there. Okay. The open segment portion is created on my lathe. This particular angle iron, aluminum, it's aluminum angle, and that point is at exactly the center of my lathe headstock, tailstock. So it's exactly from the bottom and exactly from the side. So it's exactly centered. This, my pictures are jumping around a little bit, so let me continue. Well, why is that happening? This is an adjustment to adjust the placement of the open segment based on the diameter of the vessel that I'm working on. These are segments that I'll be doing the open segment on. The next part of the segment process is for me. I created a disc with indentations and a spring-loaded. This is a hacksaw blade with a brass 1/8" brass rod epoxied on, held onto my bed of the lathe with magnets, as is the table for my segments. So here's how segments are put on, a little short video. So I put glue on the segment, put it up, push it against the stop, hold it in place, and get it ready for the next one. And as you can see, I'm holding probably 3-4 seconds. That's long enough for me to get enough tack so I can move on to the next one. When I finish the entire roll, I will probably wait an hour or more. And if I need to, I'll sand the surface of the roll so that I can apply the next roll. So I'm doing one roll. This row here underneath is solid closed segment. This row is open segment. and it alternates all the way up through the part. And I did the vase let's talk next slide here. These are devices I use to center. The next roll would be a solid roll, a roll, and I use these devices in my tailstock to center that roll onto the closed segment onto the open segment. And here's the video of the finished project. So I combined the technique of open segments and closed segments together. My next project is actually a group of several projects, but they all have the same thing in common. So that's one item. This is another, another, another. And they all look as though I've been able to do some very unusual techniques here, but the technique is very simple, and here's the clue. It's actually an arc. It's an arc. It's strictly an arc cut on a bandsaw. And in this case of this one, it's still an arc cut on a bandsaw, but I rotated the chuck a little bit so that I get this particular design, and the possibilities are endless. So in some cases, it's just open cuts with part of the thing brought in. Other cases, it's pieces of veneer, and it's cutting a second bowl in order to get this particular piece. So I've actually had to create two bowls to get one. Okay, here's the fixture I use. I take my bowl in the bowl and chuck, screw it on here, and this plate allows me to bring it forward and back. I have a stop so that I can stop exactly in the center of the bowl. This fixture is rotatable. Here's the back side of it. Rotatable, and I can then swing an arc through the part, and that's what's causing these particular designs. And then they're at the end, they're re-glued back together again. Okay. Okay, next project. Curved segments. This is also done on a bandsaw. And in this case, I've glued a piece of paper to a piece of MDF. And this was one of my fixtures. Using that, using a table, and I have a pivot point here on my band for my bandsaw, and this is adjustable so I can create any arc. These holes out on the end are the holes, the pivot holes. So in other words, to get this arc, I'm at one of these pivot holes back here. So, and I do not go through the center. And I also stack the two different species of woods, one on top of the other, so that when I actually cut the arcs, I wind up with material enough for two bowls. So, and then after they're cut, I glue them together. I do not sand the surface that I cut on a bandsaw. And here you can see this is a piece that's cut, and I do not cut through the center. I cut that center portion out later. But that's one of the pieces that I've cut, and here's the end result. So I'm using, then I'll cut it in two pieces, and the hole that I had is filled with that, and then I can use the two pieces for two parts of the vase. I can also, or it's a box, and I use a solid piece for the bottom of the box. Okay. Next project. This project is made with half bowls and quarter bowls. This arc here represents a half bowl. This is a half bowl. And I think there's 9 quarter bowls. So all these other arcs are all done with quarter bowls. The way it's designed is taking street L's, and I use the plastic ones, it's fairly cheap. And anytime you can, any configuration where you can make a closed loop, you have made the parts. So this loop here, 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 and here represents a half bowl. This is a quarter bowl. This is a quarter bowl. So this is mock-up is not does not represent the finished project, but just to show you that any way you can make a complete closed loop, you can actually make this out of wood. So let's go back to this thing. These are all individual staves, and I make the staves on a sled. This is my sled for making the staves. And the stave angle is 7.9 degrees. The miter angle is 81.99 degrees. These are theoretical, mathematical developments, but in essence, what you're doing is trial and error until you get your parts fitting together. They also, every piece you make, let's go back to this to show this again. Every bowl has to be exactly the same, the segments have to be the same length, and the bowl has to be exactly 45 degrees. If it's at some other angle, you do not get a closed loop when you try gluing it all together. A purist would only make 1/2 bowl out of a bowl, but you can cheat, and then the cheat kind of bites you at the very last to get the very last joint back together. So you're kind of pressing things together, but you must do very accurate turning. The thicknesses must all be turned the same. The 45 degrees must all be very close to 45 degrees in order to get a unit that actually closes itself when you do the finish loop. Some of the joints, in order to get the joints together, you gotta put in, I put little blocks of wood held in place with a hot melt glue, and then blocks on both sides of the piece. So there's 4 blocks, and then hold the blocks together with rubber bands to not only create the individual bowls, but also to create the finished product and to glue the thing up. So it's a tedious job, a lot of gluing. Next project is one of these head scratchers. I said, what would happen if I made my segments different widths? And what would happen if I made my segments tapered? So this is the end result. And here you can see a little more detail. You can see I've got some wide segments, some narrow segments, varying length, varying width. Um, they look like they're random, but they're really not. They were, for every time I made a wide one, I made a very narrow one to compensate. So when I glued these rings together, they actually formed more of a rectangle than a circle. But that's the way it worked. Um, to do the angles, I created a sled for my program keeps jumping. I created a sled to create these angles on the drum sander. So I created an angle here, this angle, an angle here, and angles here. The center two pieces, or the center ring has no angle, and that was my composition to bring the things together. So they're the two complementary angles on top and two on the bottom. I made the angles so they complemented each other. So, and the unit was turned in halves so that the unit is hollowed, but it's made in two halves and then glued together in the final turning at the end. Next project. This project, the feature, the intent here is to have a scalloped edge. And the way that's made is by making the segments scalloped. And I'll show you this. These are the Forstner bits diameters that I have in my possession. And that limits the scallop. So I can't make a scalloped edge to a dimension I don't have a bit for. And I'll show you how that's all done. I cut segments in the normal way on my sleds on the table saw. But one of the problems that manifests itself on this particular design is I have to have a pivot hole exactly in the center of each segment. And I've learned this technique probably 10 years ago from another turner, and I never could get it quite right until just recently. It dawned on me to use a milling machine and allowed me to measure exactly across the area by using the milling machine and its accuracy and movement, and then coming and spot drilling a hole exactly in the center. So I can, this is a stop, this is a stop, and allows me to drill a hole exactly in the center. Okay. With that hole in the center, I could put it on this pin, which is the spot hole, put it on that pin. And then in the next picture, I can then sand an arc. And I sand that arc so that it fits into one of these tools for measuring that arc. So I have to sand that arc. It's a trial and error process so that it fits into one of these gauges. Okay. So here's the technique. Here's the result. And the next piece that I create, like this walnut piece here, I create that by using the Forstner bit. That gives me the inside surface, and the sanding on the drum sander gives me the outside surface. Here's a variation of the technique. And when we go back to this guy, so when I glue these segments up, I do not do any turning on the outside. So I'm only turning the inside, and the hole that in this particular piece, the hole, this pivot hole that I had started breaking through on the inside. So this walnut ring was added to hide that hole. So um, was not originally intended, but that's the way it came about. So, okay, next project. I thought this would be kind of an interesting uh, concept to kind of show what might happen if like squashed one side of a bowl or something. And my idea was to make segments and then put them on an angle. You see, it's thicker on this side, thinner on this side. That was done on the sled. So I created a 4-degree angle, and this is a sled. I put the the disc on, and then ran it through the drum sander until I had sanded it to that angle. My intent was, because I have 9 different layers, my intent was at 9 degrees each layer, or 4 degrees each layer, at 9 rows, I would have a 36-degree slant. As it turned out, it came out to 34 degrees. My thought was, as I added, well, let me go one step, show you the rest of the process. I took out 2 jaws out of one of my chucks, and I took and glued this block on a base, and this is what I put into my chuck. And here you can see how that was. And as we went up as we added rows, I would move this chuck over as I added rows. My intent was to turn the junction between the last row that I added and the previous row. As it turned out, I did a lot more carving than I did turning. But that's what happens when you try something new and experiment with it. So this is more of an experiment. I also had tried designing the bowl to have a more unique shape to it, because it wound up to be more of a carving project than a turning project. This is the result, but it's an interesting thing. Okay. Next project. There's a turner in Israel named Ali Avicera, and this is a design that's unique to him. But it's an interesting design, and I thought it would be nice to make something similar. And he does it, he uses design on bowls and all different kinds of things. But candlestick holders is probably the thing he does the most of. But I've never seen anyone else make this design. And I tried making this thing many times with zero success. These the to get these points all together and get these arcs and everything to match is a and here you get a better idea of the pieces. Um, Real process in precision glue ups and accurate turning. And I finally resorted to cutting my pieces using a milling machine so I could maintain the accuracies so that all these, like these four pieces here on all four sides have to be exactly the same. These corner pieces have to be exactly the right, and everything has to be right on in order to get this to work. And I finally succeeded by cheating by using a milling machine to get the job done. So, um, but I think it's an interesting design. This is a, this is probably a pretty commonly type of turning. It's done by this three-pointed box is done by creating a cube and chucking the opposite corners on and turning it. The big problem that most people have once you turn the opposite corners is you have to um, chuck one end into a chuck in order to turn the inside. And the problem is there's not enough material here to chuck into the chuck on the lathe. So one of the secrets is in making this is to glue an extra piece of wood or three extra pieces of wood on one of the corners and then turn the tenon on that and use that extra piece as the tenon to turn the inside of this ball. So the whole secret of being able to do this is to create an extra material on here so that you can get a tenon to hold apart carefully. This one is making segment rings and gluing only these two pieces together and these two pieces, but not gluing the walnut piece in. And then stacking it on top of the other one and gluing this joint right here, between here and gluing this joint. And then pulling these pieces, the walnut, after all that glue up, pulling all the walnut pieces out and carefully marking them so that they go back exactly in the same hole. So then when you get all the walnut pieces out, you turn the maple piece, put the walnut pieces back in and return it. Jerry, are we at the point you want to be at?
You're this far. You only got about a couple more slides. Why don't you go ahead and finish?
All right. You want me, oh, you really want me to go through the rest of these? All right.
Yeah, you ain't got that many left.
All right. Um, this is typical open segment. We talked a little bit about how to do open segment work earlier. The sphere was done in two halves and then glued together. This bottom piece was made on an old legacy machine. This is a project I made 10 years ago. And it was done on a legacy machine that had a router that cuts the material. It was, I think the device was called a router lathe. And so I made, a friend of mine had this machine and I turned that part. As I recall, it took me longer to sand it than it did to actually carve the design. And the base is standard turning. Um, this device, this is a cricket cage. This was made on a Rose engine. A Rose engine is sort of a lathe, but the cutter is part of a revolving device, or you could put a router bit in as a cutter, and these grooves and slots were all made with an 1/8 inch bit, and so it's a device that you can accurately index and use a router to cut a particular length or a spot. And it's a type of, it's a part of a turning device, but called a router, called a Rose engine. This is another device on a Rose engine, and this is where you actually create a device that wobbles. Uh, um, it's a following device that wobbles the cutter so that you can actually cut these patterns. And as you cut the pattern, you can actually rotate the device. So I've got the same pattern on the inside as on the outside of the device. This is purely a sculpture. It's made by taking a piece of steel wire and bending it to the shape that you like. You create the shape. So um, the fellow who taught me this thing had made sculptures 8 foot tall with the same technique. And then the individual pieces, they're individual segments, probably in this case about a 1/2 inch wide, a hole drilled in the center, and then you use the disc sander to sand a flat. And so you slide it on, you sand it flat, you sand it mating flat, and slide on the next piece and go on. And it just pieces glued onto a piece of wire. So the design is wide open, so you can do any kind of shaping you like. Next slide here is combining basket weaving with turning. And made a form. One of the guild members, Vern Eilers, taught me this technique. And we made a form for the upper portion and another form for the lower portion. And we wove the basket design, and then we turned the rings and put a groove and then fitted the basket weave into the groove here and another groove up here and likewise here. So it's a technique where we did some basket weaving and turning as a unit. Last slide is I'm willing to share any of these designs or help you with, there's an interest. here's how I can be contacted. Be happy to share any ideas, or in some cases, I have plans for some of these devices. Um, It's an open share. Thank you.
Thank you, Jerry, very much for doing that for me again. I really appreciate it. And
Let me get out of here. We can talk for a minute. All right. So, Jerry, what are you working on these days?
not much right now, to be honest.